So the first assignment, first part of the first force assignment, we had the game, meme game. Here we used reinforcement learning. Reinforcement learning is a branch of machine learning that uh, agent interacts with environment, and we don't give them the labeled data. Like we don't hard code them. Our agent tries to learn it by itself. We just give them the rewards if it makes a good move and the penalties if AI makes a bad move. Here we implemented the get Q value. It basically returns the Q value for the state and the action A. If no Q value exists yet in self, it returns zero. Basically here it's like trains like 10,000 times and with AI plays with itself. And if we don't have the Q value for that particular move, we set zero. Otherwise, we get that from training self. Here at the Q value, we take the state and action and alt value. Here we give the reward. And the next thing is best feature event. It basically checks for all available actions and it returns the max out of them and max Q values out of all actions. Choose action, it chooses the max between get Q values and available actions. Here it chooses between, it's like 10% of the time we choose the new epsilon element, like we don't know, and other 90% of the time we choose from the best. Here's the train function. It trains AI with itself, just giving the pile here how it's play. We have uh, let's run the code. We choose the pile. We have four piles. It's like set. We have to turn it to tuple. Like we choose the tile one, and from three to I want to take four. Here is the AIs, and so I lost here. Yeah. So the second part of the first time, here we first of all input the necessary libraries. Like usually, the second step is creating dataset. Here I created these attributes columns, so using the randomize it, and our target in the linear regression model is our final score. It's like linear values. Here on the final result, it depends on the final score. It's our categorical value, whether the student has passed and failed. Here is a creating data frame using that attributes or columns. Here is the student behavior um, dataset CSV file. Here's the basic statistics using the describe, like count, mean, standard deviation, minimum, maximum, and the quartiles. Can prediction whether the student has passed the classes or passed away. Basically, KNN means key nearest neighbors. We set the key, and depending on that key, we choose the nearest neighbors k count. Here I used all of the available features as our x independable variable. Here's our target is final result categorical value. Here I choose the key using accuracy score and predict. Here I choose the best key within this range. As you can see, 6, 8, and 10 gave me the best results with accuracy 1. In KNN, we should not use even numbers because we might have same number of passed and failed. So we should use odd numbers. But because 6 gave me the best result, I printed the classification report using that. Okay, here is the visualization part, and as you can see, here's our white dot is our test. Test from test. I mean, usually we split the dataset into test and train, train and test. We check. It's the test size is usually 20% here, and other is going to be train. Here's the blue dots is passed and red dots is like training and yellow dots is our neighbors, nearest neighbors here. So according to that, we predict it as a fail and it's true. In linear regression, we have to predict our final score. Like it's a linear target. Here's our features. all features, and the final score is like points 20, 25, 80, and so on. Declaration, linear regression, we fit on training and X training and Y training. R is basically mean squared error, MSE, and root MSE is basically MSE root of root mean squared error. Here's the data frame and the coefficients. And yeah, as you can see, you can visualize the result. As red dots is our actual actual scores here, and predicted as blue dots are predicted. As you can see, I added also noise feature importance here. Assignment completion plays a huge role. Phone usage, stress level also plays huge role, but negatively. Here's this coefficient is less. What happens if study hours increases by 2? It improves plus 20 points. Basically, some experiments. This actually, the dataset was made by a hand, so these coefficients are here. Study hours plays a huge role, plus noise, some randomly. If we delete this, probably we will gonna get 100% accuracy. Basically, our linear regression will get this coefficients and put that into testing part. This third part is our key means clustering grouping students. Key range is basically from 2 to 9. We don't choose the 2 because it's not how to say, it doesn't affect improve our clusters. Here we choose 3 because after 3 uh, our inertia will significantly drop, and it's a unsupervised learning. We don't have labeled data, we don't know our target, we don't have the right answers, so we basically split the dataset students. Here PSC principal component, um, it, we set our key to uh, 3, and it will generate 3 randomly at first centroids, and by step it will um, group the other dots closer to that centroid. Here are centroids.